this video, we'll be going through the basic structure of our measurement systems, those measurement systems that sense a physical variable and actually do something with that physical variable and display something with that physical variable. So we're going more higher tech than just a plain thermometer. We're going to actually trying to do something with that data and use it in some useful way. And typically, this is the ecosystem that we operate within. You see on our far left, we have an input, some sort of a true value, which is our physical variable. Now that could be anything from temperature to pressure, to force, to acceleration, location, to distance. There's a whole bunch of different physical variables that we could be wanting to sense. Voltage, current, lots of different ones. Now we have some sort of a sensing element. We have some sort of often signal conditioning element. So something we do to that sensing element to improve that data somehow. We'll go through these in detail. And then we have some way of processing that signal and then presenting that signal, because at the end of the day, we actually want to see what it is. Now, once we've presented that signal, we get our output, often an output that we can maybe hear or see with our eyes or something like that. And that's our measured value. So we have our true value, which is our input value, and our measured value, which is how we try and quantify what that true value is in a way that we can understand, in digits that we can understand. Now, I should say that we have a bit of a divide here, an analog and digital divide. And our analog divide is basically where we're in the analog domain. We're dealing with continuous values of temperature or pressure or voltage or whatever it may be. Continuous values. In our digital domain, we've quantized them. So we put them in little buckets. Now, if we've got a high resolution system, these are tiny, tiny little buckets, maybe millivolt buckets or hundreds of millivolts or something like that. And they're discrete values. So there's discrete steps, where our continuous one is just a continuous particular value. When we're dealing with our digital side of things, we actually need to quantize these, so it's a way the computer can represent it and make it easier for us to understand and make decisions based on, for example. So let's go through each of these elements one at a time. First, we have that sensing element. And basically, this is where our sensor's in contact with the thing we're trying to measure. So it could, for example, be a strain gauge trying to measure mechanical strain on a beam where it's deflecting. And so here, our resistance of that strain gauge will vary as we have force that's applied to our beam or whatever it happens to be, a load cell, for example. We might have a thermocouple, and we use a thermocouple to measure temperature. And the thermocouple will vary by millivolts depending on what temperature is applied to it. We might have a flow sensor, and our voltage output might be dependent on how quickly a little propeller inside our pipe is actually rotating around. So, bunch of different sensors producing output in a number of different ways. For example, we have resistance there, we have voltage there. There are other ones as well. Our next part is the signal conditioning element. And basically what we realize is often the sensor data needs improvement somehow. Maybe the sensor data is really tiny. We're talking like millivolts, really small volts. And we need to boost that voltage up by amplifying it. And that means it's something that's easier for our computer to understand. Maybe there's a certain noise associated with that sensor. Now, next week we'll be discussing noise in detail. But maybe we've got some high frequency noise or some low frequency noise, and we have some filtering elements to filter some of that out. So there's some examples there about filtering, amplification, or maybe using a bridge like a Wheatstone bridge, which isn't a new technology, like these are 200 years old, to allow us to measure resistance to a very fine degree. Well, let's go with a signal processing element, which is where we move over into the digital domain. And here we convert to a form that's more useful to present and use in whatever system we're doing. This is the area where we'll start using our analog to digital converter, which is something on a little microcontroller. I'm not expecting you in this class to know them in detail, but basically it samples a voltage, converts it to a digital form which our computer can understand. So we have a voltage, take a AA battery, for example. We want to work out what that voltage is. It might be 1.55 volts, and we want our computer to actually understand that and be able to record it. Our computer might be recording, for example, a number of pulses that come from something. And you see above here, we've got a little rotating disc. We often have a little light source across that disc. And as that disc rotates, the light source is interrupted and not interrupted. And we'll have a little waveform that's like a square wave. That can allow us to measure, for example, how quickly a wheel's rotating. We might do, at this stage, some digital signal processing as well, where we might do some averaging of data or some digital filtering to remove noise. So there's lots of different things that we can do in this signal processing element stage. And finally is our data presentation stage. Now here, we're presenting our data or the measured value to an observer. Now, I should note that that observer could be a person that is looking at it with their eyes or listening to it with their ears or something like that. Or it could be a control system. For example, we might have a heating system that we want to work out, okay, we'll turn the heater off when we reach a certain set point in our temperature. And so that will feed back into our heating system, and then eventually it will cool down again and the heater will turn on again. So it could be a person, it could be a control system. There's some basic examples there. All the data might be written to an Excel spreadsheet or a CSV file on a little memory card or something like that. It might be on a little LCD screen or something like that. It might be printed out directly on some sort of a line printer. It might be on some sort of a fancy HMI display or a display that we create in MATLAB or LabVIEW or something like that to show us what's going on across our system, what sort of measurements are being made. It might be a website, for example, that's uploaded. So lots of different areas that we use to display this information, lots of different ways we can do that.